Thank you very much. It's my pleasure to talk about our smart city project in Saitama. How to move? Playback. Okay, I see. Thank you. I'm sorry. Okay, so where is Saitama is located? Saitama City is located about 30 kilometers away to north from the center of Tokyo. And in Saitama City, we have several smart town projects. The biggest one is the UDC-MI, where the name is Urban Design Center Misono. And the consortium of UDC-MI is composed of these kind of members, Saitama City and universities and the major and local companies. And here in UDC-MI, we provide many kinds of services by using IoT sensors as shown in this figure. So I'd like to show the brief of this kind of sensors, but here I want to focus on all the major data is concentrated to the cloud. It is designed by the Microsoft Azure, but it also goes through the UDC-MI edge server that is located at the intermediate place of the network. So that means we can provide a service by using cloud, also by using an edge server. So here we implement the BLE antennas, and we can provide a location service by using a BLE beacons, as shown in this figure. So we provide a smartphone application to locate the users' belongings, like school children and a pet, like a dog, a cat, or bicycles. As shown in the figure, we implement 140 BLE antennas in the town. So the merit of this system is beacon is very small, and it can survive more than 2 years by using a very small battery. And also, we implemented a health monitoring system in this town. So we also delivered this small device. It's a health tags. And the tag can connect with the body composition meters and also the kiosk terminals in the shops. So we can get the health condition data by using this device, and also the purchasing history data can be taken by using these systems. And on smart houses, we implemented now 30 smart houses in this town. And in this smart house, we implemented many kinds of sensors like temperature, humidity, luminance, and carbon dioxide, and outdoor environment like PM 2.5, and many kinds of data taken in these sensors. And by using this data, we can provide an eco-recommendation report for saving energy, like this. This report is automatically generated by using machine learning technology. So this is maybe the common way to provide this kind of service. The data is taken in the town, and the data is directly sent to the cloud. The cloud stores the data and analyzes the data, and maybe the program on the cloud provides the services. Okay, this is maybe common way, but the UDC-MI, we provide the alternative way. So the data is created at town, yes, but it's also stored, analyzed, used, and anonymized at the local. That means all the private data is encapsulated in the town. And the data is anonymized at town. That means cloud can use the anonymized data. So we can provide the cloud services, but the cloud service have to use the anonymized data. So by using this way, so cyber attack cost becomes high, because if you want to attack the private data, then you have to attack one by one that is stored in the town. So this figure shows more briefly about this service architecture. The top one is a very common way. So the smart meter sends its raw data to the cloud and provides this kind of report. So next one is our way. So ASCA is authorized stream content analysis. So the smart meter directly sends the data to the cloud. That means this IP address of destination is a cloud. But in the edge server or router or switch, they can function of ASCA and take the layer 7 information at the intermediate point of network. So by using this system, so we can anonymize the data and also gives a watermark to the data directly. So you can say that we can enhance the function of the smart meter or kind of IoT devices. So this figure shows the architecture of SCA, but I'm sorry that for time reason, I want to skip the detail of the SCA, but I want to focus on this. By using this SCA, we can decrypt the SSL encryption because we share the encryption key with cloud, and we can decrypt the gzip, we can decode the junk, and over the 2 million TCP streams can be analyzed at the same time. So by using this ASCA, we can provide many kinds of new services like protect the IoT devices from intrusions because ASCA can act as a firewall. And we can provide surveillance of the suspicious looking access because ASCA can monitor all the transactions between the IoT devices and cloud. And it can find and remove the phishing attacks because it can manage the route because it can ASCA is implemented on a return switch. And it also provides new services using user behaviors of the internet because it is also implementing the intermediate node of the network. And it can solve the problem of privacy revealing. As I said, the ASCA can access the contents of the data and anonymize it. And finally, it can provide time-critical services because it can shorten the latency of the service providing because it is close to the town. That means that it is close to the IoT devices. So here is the development history of ASCA platform. Firstly, we start the ASCA platform by using a conventional, high-end commercial routers. It's very expensive. But now we can successfully design by using this small Intel NUC personal computers. So it becomes much cheaper than that. So we also use this system into the UDCME. Oh, yes. So I want to show some demonstration. Oh, I'm sorry it has a movie, but I'm sorry, yeah, the movie does not move, but okay, I'm sorry. Okay, so, I'm sorry, the movie does not move, but by using this interface, we can distribute all the application program by using a Docker container. All the service program is implemented by using Docker, and we distribute the Docker to the cloud and router, switch, and is implemented by the ASCA. Next, here I want to show is, so smart meter data is directly sent to the cloud, and we can provide energy reducing report. But also, by using ASCA, we can anonymize the data, and also we can add the watermark into the data. And we can, also the data is anonymized, that means the data is changed, but still similar data, similar service can be taken by users. So that is what I want to say by using this demonstration. But now this system is just only designed only for the smart meter. Now we will extend this function to the location services and also the patching history services. Thank you very much.